Let's just solve this question priority queue maximum, which is also called max heap. Okay. So let's try to read this problem statement. And priority queue is very important concept in term of STL. So definitely try more question about that. We'll try to put more question of priority queue base. So here is the implementation of priority queue, the basic how to use this priority queue. So you have an empty array A of integer. You have to queue queries in the format. We have push X and add X to the end of the A. Pop is remove the greatest number in A, and top is a print the greatest number in A. So we have a two types of query. So we have to push, we have to top, and we have a pop. So we have three types of query. So you have to check it out. Okay. So this is called the max heap. Okay. This is called a max heap. And in max heap, the implementation is like you know that the similar thing happened with queue, which is integer queue, and the implementation is very similar. You have to write priority, but the internal implementation is very different. It is because it is a tree-based algorithm. Okay, it's a non-linear data structure algorithm. So it is a tree-based algorithm. So this is the priority queue in the max heap. But whenever you really want to do mean heap, the declaration of priority queue is different. So the same priority queue int, you have to write int, and then you have to write vector of int, and then we have to write greater int. Greater. So this is the mean heap priority queue. Okay, you have to write. Okay, so this will give the mean answer. Okay, so this is the thing that you have to do in the mean heap. Max heap is the very simple. Okay, what is the feature of max heap? Max heap, the top element is always maximum element. Okay, so it is print like the top element is a max. Okay, if you really want to check the internal implementation, you can check the Google or you can check the YouTube. The implementations are great. So so let's try to implement this code. So that's it, P2, and this is the max heap. Okay, this is the declaration of max heap. Okay, so for a scene n, for I equal 0, I less than n, I plus plus, and string s, scene s, and if s equal push, else if s equal top, else if s equal pop. Yes. So in else if you don't need to put because we have only three. So else is part definitely s equal to pop here. That's it, and we check ll val and scene val, and we have to push it pq dot push back. And in the top element, you have to print this. Print the greatest element. So top element is the greatest element. Okay. So here, see out pq dot top. Right? And whenever you really want to remove the element, you have to go pq dot pop. The very similar thing that happened using the queue part. But a queue is a linear data structure. Okay, I'll tell you. Queue is a linear data structure, the internal implementation, linear DS, but priority queue is a tree based algorithm. So it is a tree. It's a non-linear. Yes. There's an internal implementation are very different, even after looking very similar. So that is a max heap. The mean heap part is little bit different of implementation. Okay. So try taking next. Just submit this part. So the code will become accepted. Okay. Let's mark this